So far, we have been executing one task at a time, but sometimes we will have many tasks that we want to execute simultaneously. We can do that with Task.WhenAll. With Task.WhenAll, we can have a list of tasks, and then we can await them all at the same time, so they will be executing concurrently, and when all of the tasks finish, we will be able to continue the execution of a method. Let's see that. We are going to do an example in which we want to process multiple credit cards, and for processing we are going to use our web API. So let's do that. Let's go to the Solution Explorer and let's create a new controller. Let's create a new class here. We're going to call it Card Controller, and we're going to minimize this. And as always, we're going to inherit from controller base, and we're going to say route API/cards and API controller. Here we're going to create an HTTP post action, and I will say public async, and we're going to use asynchronous programming here. So we're going to say async task action result. We're going to say process card, and we're going to say from body a string. We're just going to receive the card number. Now, something that I want to do here is to be able to use random. We need the random class because we want to pretend that some cards will be approved and some others will be denied. And so, in order to randomize that process, we are going to use the random class. Though we cannot just simply come here and say random because we are in a multi-threaded environment. And the random class does not work well in a multi-threading environment, as we will see in the parallelism module. So what we're going to do is that we're going to introduce a service that will allow us to use effectively our random class. So let's come here, right click, add, new folder. We're going to say helpers, and we're going to add a new class. I'm going to call it random gen from generator, and I am just going to paste the following code. Now this code allows us to circumvent the problem in which the random class doesn't work correctly in a multi-threaded environment. Basically what we're doing is that with the thread static attribute that we have here, we are saying that every thread is going to have a local instance of the random class. And then for initialization purposes, we are using the RNG crypto service provider to initialize our random class with a random seed. Again, this is something that we're going to study on the parallelism module, so we're just going to leave this like it is, and we're going to go back here to the cards controller because I want to use that service. I will say here random value equal to random gen next double, and I will do the following. I will say approved, and as we said, we want to have the approval of the card randomized. So we're going to say random value is bigger than or greater than 0.1, and remember that this next double method returns a value from 0 to 1. So basically 90% of the time we're going to have this equal to true, and in those cases the card will be approved. And we're going to say await task delay, and this is why we need async, because I am going to do a task delay of 1 second. Notice that I can use milliseconds here, or I can use time span from seconds if I want. Now I will say console write line, I will use a string interpolation, and I will say card process. And finally we're going to say return OK, and I will use an anonymous object here. I will say card equal to card, and approved equal to approved. And that's it. Now, as we said, our goal is to have many cards to be processed by this simultaneously. We may have even thousands of cards. So let's do that. Let's come back here to our WinForms application, and first what we need is to have a list of cards. For that we're going to create a helper method here. We're going to say private list of strings, and we're going to say get cards, and we're going to send the amount of cards that we want to generate. Amount of cards to generate, And here we will say cards equal to new list of a string for amount of cards to generate, and we're going to say cards add I to a string, and we're going to do some padding 16 and 0 here. This will allow me to generate values like 00001, 0002, and so on. Of course, we will have at most 16 characters here. And then we will say return cards. Now let's use this method from here. We can clean this up a little bit. We don't need this here, nor this, nor this, nor this. Okay, so now what I want is to have bar cards equal to get cards. And we're going to start with 5, but later we will say a bigger number. And then we will invoke a method that will simultaneously make the corresponding HTTP request. So let's say private async. This method is not going to return anything, so I can say task here. Process cards is going to be the name, and the parameter is going to be the list of cards. Now I am going to need to do some serialization here, so I will install Newtons of JSON. So let's come here, and in the WinForms project, let's say manage NuGet packages. Let's go to browse, and let's click on here, Newtons of JSON, and let's click on install. And that is done. So let's close this, and let's go back here, and let's go back here. Now we're going to say for each card in cards, we're going to make an HTTP request for each of the cards. So we're going to say the following. We're going to say JSON equal to JSON convert serialize. We're going to serialize the card. We're going to say content because we need a string content representation. So let's say a string content, and we're going to say JSON, which is going to be the card. We're going to say encoding UTF-8, and finally the media type is going to be application JSON. And then I need to make the HTTP request. So I will say response task equal to HTTP client post async. I will use our URL, API URL /cards, and we're going to pass the content, the string content. Now, notice something, and that is that the data type of this variable is task of HTTP response message. That is because we're not doing an await here, and we don't want to use an await because I don't want to await for the task individually. I want to await them as a group. So for that first, what I'm going to do is that I am going to create a list of tasks. So I will say tasks equal to new list of task of HTTP response message, because remember that this returns a task of HTTP response message. That is why I am using HTTP response message as the return type of the task. And now let's say here tasks add response task. And we made a mistake here. It should be response message, HTTP response message. And now we don't have an error here. And now I can use our Task.WhenAll. So I can say await Task.WhenAll tasks. So as you can see, with WhenAll, I can do the following. I can say, hey, here there is a list of tasks. Please wait for all of them to be done before continuing with the execution of this method. And all of the tasks are going to be run simultaneously. So if I have to do 5 requests, those 5 requests are going to be made simultaneously. Let's see that. Let's go up here and let's invoke our method await process cards, and let's pass the list of cards, and let's prove that our method is not going to last 5 seconds, because remember that here we have task delay 1 second and we have 5 cards, which means that this is going to take 5 seconds if we run this sequentially. But since we're going to do simultaneous execution, it will not last the 5 seconds. Let's see that. Let's say var stopwatch. We're going to use a stopwatch, new stopwatch, and we're going to say a stopwatch. Let me put it here before the process cards. Let's say start, and then after that here we're going to say something like message box show operation done in, and we're going to say stopwatch elapsed millisecond divided by 1000, and we're going to say seconds. We're converting here milliseconds into seconds, and we're displaying that to the user. So let's make a test. Let's press Ctrl F5 to run our application, and let's see that we have our WinForms application here. I will click on Start, and then, as you can see, after 1 second, all of the 5 cars were processed. Let's see that. Let's click on OK, and let's go to Build, and let's go to Web API, and as you can see here, we have that the 5 cars were processed in the server. And not only that, as you can see, it is not order. We have 3, 4, 2, 0, 1, because remember that since the execution is simultaneous, then it means that we cannot guarantee the order of execution. We know that the 5 cars will be processed, but we do not know the order in which they are going to be executed. Now let's push things a little bit. Instead of 5, let's say something like 1000. Let's make sure that we close this, and now let's run our application again, and let's see how long it takes to process 1000 cards. Let's click on Start, and let's see. And as you can see, it only took about 1.7 seconds. So that means that we did 1000 requests, and as you can see here, we have 1000 requests made to the server in about 1.7 seconds, which is great, which shows the power of using mechanisms like Task.WhenAll. Now let's keep pushing a little bit. Instead of 1000, let's say 25,000. And let's see what happens. Let's close our application and let's run it one more time. And let's click on Run and let's see what happens. As you can see, I click on Start, but the loading GIF didn't show immediately. So we have one problem there. And as you can see, it works, but there will be some web APIs that will not allow us to basically spam them with so many requests in a row. Sometimes we need to scale down so that we do not end up saturating the web server. So then we have two problems. We have one problem, that is that when we click on Start, we don't immediately see the loading GIF, and the other problem is that we got asked to not send so many requests at the same time. In the next video, we're going to solve the loading GIF problem, and after that, we're going to see how can we throttle the amount of HTTP requests that we do simultaneously.